And I just remind you, we're recording the session for anybody who needs to view it later down the track, but we can't see you. But if you do sort of have a chat, that'll be recorded, but I'm sure that'll be very valuable to anybody who does watch it down the track. So pop in any questions now. Once you finish this module and you do the last quiz, and I say quiz with quotation marks because it's only one question after the end of this one, and it's how many Wallies. And so just do keep an eye out for Wally. But once you do that and you've submitted your assignment and everything has gone through and you've got over that 80% average mark across the board, you will get your certificate and emailed to you, and then it's sent in the mail as a hard copy. So it doesn't look like there's any particular questions there, Jamie. So Jamie, would you like to start with one of the specific site challenges that came in from the group?
Sure. Yeah, we've had a few come in, and they're all good ones. The first one is from Emily, and it's West Moona in Tassie. I'll try and share my screen. I hope you can all see a photo there.
Yep, that's good. You might want to zoom in a little bit there for us, Jamie. Yep.
Here we have 2nd Avenue in West Moona. We have a retaining wall here, Emily tells us, and there's about a 5-metre drop beyond that to a service road. There was an incident where a taxi driver was looking at his GPS and he didn't take the bend and went straight off. So Emily's question is, would you put in a pedestrian barrier or a road safety barrier? I would suggest installing a road safety barrier here, which would serve the two purposes of containing vehicles and also highlighting the presence of that drop for pedestrians. If you did put in a road safety barrier, it's going to need to be one with a bolt down post, or it would need to be bolted to the side of that retaining wall. I'd suggest you would want to use a strong post guard fence system. We've talked about proprietary and public domain guard fence products. Sometimes you might hear the terms strong post and weak post. The proprietary products are weak post systems, so the posts bend readily on impact. Here, because of the speeds, the relatively low speeds, we could get away with a semi-rigid system, a strong post system, which we could bolt down. Terminating the system would be interesting. I might show you another photo. At one end, you can see there the start of the retaining wall. So it's a pretty tricky spot to be terminating, and ideally,
in this photo hasn't moved on, I don't think.
Still got the same photo, have you?
I think we do, or I do. Maybe stop sharing and then reshare.
How's that?
Yep. Beauty.
Photo. So this is the very start of that retaining wall. So starting and terminating the barrier is going to create some challenges. If you have ideally we'd be providing a crash-worthy end terminal, but you can see there's a curve there. Any terminal must be straight. If a terminal ended here, maybe the back of that system would be a potential hazard to someone on the service road, potential snagging hazard. So there's certainly some challenges there, but probably the greatest risk exists at that curve. And because of the speeds that we're encountering, how you terminate it is perhaps not, sort of the end of the world if we can't get a conforming solution at the terminals.
Okay, that's a good one there, Jamie. Thank you for your thinking around that. Pop in any questions anybody has around sort of Jamie's thinking in that scenario. Did did the sort of speed factor into that decision there, Jamie, or was it sheer that that big drop that was the real driver?
Speeds is a factor in terms of how your barrier might look. Because the speeds are relatively low, and I don't know quite what they are, but I'm assuming that they're sort of perhaps in the order of not more than 50 k's per hour. That means we can get away with a semi-rigid system. Your choice of terminal, we don't need to be going with a long grate or anything like that can withstand impacts at high speeds. It's more that secondary event where someone goes over the retaining wall that we're trying to prevent. That's the high severity outcome, I'd suggest.
Okay. Now, Richard has just sent this one in from South Australia there for just a quick little look at. And I thought that, there was a little bit of similarity in what you were talking about there. So I popped this one in. Jamie hasn't seen this before, so he'll be quickly looking at it. But that sort of cranked, angled post is something that I don't think I've ever seen that particularly, and I'm not sure, is that something you're aware of, Jamie? And in this situation, would you be thinking there would be any different setups that you might do? It looks like it's sort of bolted in or something into the, I don't know exactly how it works, but any comments on that one? And Richard, feel free to pop your hand up if you'd like to talk directly to it, or if you just want to let Jamie discuss it.
Yeah, I haven't seen that situation before. I assume, like you say, Ken, it probably is fixed or bolted to some sort of foundation. A common scenario where you've got a guard fence located at the hinge point like that is to use if we're using a straight post, is to use a longer one to get better embedment. Yeah, I haven't seen that before. I'll be interested to know more.
Yeah, it's a unique one. Thank you. Thanks for sharing it there, Richard. Okay, we'll come back to a bit of that. What am I doing here? I'm stopping sharing screen. Yeah, okay, good. We're getting quite a few things in there in the chat, which I'll have a read of while Jamie runs through a few slides to get us going, some real world examples, and I will in the background collate some questions and some more site pictures for others, for Jamie to talk to and get other input. Thank you, Jamie. Over to you with hopefully some slides. Okay, yep, we're
nearly there.
Yeah, no, we're seeing it now. That's good.
I got the right screen showing there, Ken.
Perfect, Jamie. Looking good.
Thank you. So in the previous session, we talked a lot about the basics of design and the desirable things that we like to do in barrier design. In this session, we'll show you a lot of real world examples and situations where it's just not quite possible to get all those desirable things in place, and we have to make compromises. There are a range of causes of the issues that we encounter with barrier design and installation. Some of those relate to the products that are being used, and particularly the newer proprietary products have a high number of parts, and they're quite complex to put together. And especially when a new product comes onto the market, we do see a lot of installation issues. The suppliers can perhaps take a little bit of blame for that, especially in the early days of a particular product. Their guidance may not be as thorough as it needs to be. These days, though, we do see some pretty good product manuals available and even videos and the like to help installers install these products. Designers sometimes may not understand the ins and outs of the products that they're designing with. It does happen that designs are prepared without a designer visiting a site. So there might be a desire to get a particular offset or use a particular flexible product. And I've seen it too many times where designs have been put on paper and a designer hasn't verified that can actually work on site. So that really is the key first step to any barrier design. Installers and contractors, with all the barriers that have been put out on the ground lately, there's been a number of players enter the game, and those that are new to the game, there are often some teething problems, especially with these newer proprietary products. We do find a lot of installation issues. It has been the case it's been reduced resources around surveillance and the like too. So there aren't always those experienced people that know what they're looking at out on site when barriers are being installed. So it really is a sort of a shared responsibility, some of the issues that we have encountered. And I will show you some photos of various instances of these issues. There are some pictures of some of the proprietary products. Now, the ones on the left are grates that are no longer accepted for use going forward, but they are probably some of the prime examples of products that have had their share of installation issues in the past. On the right, we can see a crash cushion. It's perhaps an even more complicated bit of machinery. Wire rope at the bottom right, and longitudinal barriers in general don't have as many installation issues. There are fewer things that can go wrong, but they occasionally do, and I'll show you some more examples of those things. Common design issues include all of those things: inappropriate choice of barrier system. It might be that we have a desire to provide a flexible system, but we just don't have the luxury of the space to do that on site. Look, I won't read through those. I have photos of each of those things coming up shortly. At a bridge transition here, we obviously don't have an appropriate connection between the road safety barrier leading up to the bridge and the on-structure barrier. The desirable thing would be to have perhaps that end post sitting a bit further forward and that having a smooth and continuous transition between the two barrier system. As it is, there's a snagging hazard for any errant vehicle or motorcyclist that might leave the road at that location. Here we have a two-way roadway, and we have a trailing terminal installed on this departure end, which, going by the old clear zone thinking, was probably okay if we made the assumption that barrier was outside the clear zone for traffic travelling away from us. That's how we might have gone about things in the past. But we do know that vehicles will travel well beyond those clear distances, and a terminal of this type is potentially hazardous, or is a hazard to any vehicle that strikes it end on. So the preference there would be to install a grate, a terminal that can withstand an end on impact at speed.
Just on that one, sorry, getting that sort of run out area and the like could be a challenge. What are your thoughts there?
Yep, there's clearly no run out area, and I guess that goes hand in hand with the thinking that this barrier is only for the direction of travel towards us. The barrier terminates at the end of that gabion wall, shielding it for that one direction, and therefore only has that trailing terminal on this end as well. If we're considering both directions, it would continue quite a bit past and would have a great terminal. If we could extend it to a location where the roadside was relatively flat to get that run out area, that would be a desirable thing to do as well.
A question has come in is, do you need to provide the length of need for the opposing direction of traffic? Do you need to do that calculation as well?
That would be, yes, that would be the desirable thing to do. And going forward, that is what should be done. In this instance, I suspect the barrier was designed on clear zone thinking, so there was no need to provide a length of need for this for the one direction.
And sorry to follow up on that, Jamie, then under the two methods of calculating length of need being the run out and the angle of departure method, which one's going to give us longer from that other side?
Yeah, the angle of departure method is going to give you a longer length. That's particularly the case at higher speeds. Lower speeds, I think the difference is not so great. But I think I did mention that the run out length numbers have reduced significantly. So it generally does give us quite a bit shorter lengths, especially on those departure ends.
Thank you.
Here we have a type B guard fence in front of a tree. We might just have enough space for deflection here. You know, we'd like to have a metre. It's probably lucky if we've got that, but we're close. We certainly don't have our working width, which considers the role of a high vehicle. So a vehicle that impacts that barrier or even doesn't impact the barrier is likely to strike the tree in this area. Look, short of removing the tree, that barrier installation is probably about the best that you can do. It's a semi-rigid system that won't deflect much. Its offset from the road is not great. So the preference here would be to maximise its offset from the edge of the road, subject to deflection requirements. And it's not ideal in that we don't have working width to this higher part of the tree, but it's about the best that we can do.
So I'm gonna continue on that, because that's a question that Lachlan came up with. Actually, Lachlan's got his hand up, so this is perfect. Pop that hand up again, Lachlan, because I'm going to let you ask your questions directly to Jamie.
Yeah, hi Jamie. Lachlan, I'm from
G'day.
Council out here in the southeast of Melbourne. This is common scenarios on our roads that we're upgrading. My understanding is, being in Victoria, we're not allowed to install type B barrier unless it's all legacy products. So we're working with flexible W-beam products. How do we determine whether providing a barrier is acceptable or better than not providing one if there's a hazard within the working width?
Yeah, good question. So on type B, it is accepted at TL2, so you can use it in those lower speed environments up to 70 k's per hour.
Okay.
So your choice would be that type B or a flexible W beam, and whichever one you went with, you might want to stiffen it up to minimise its deflection. Your question about is a barrier better than no barrier at all? I would suggest that in this situation, at least, the barrier is better than nothing at all. It's going to shield that tree from the vast majority of impacts or potential sort of run-off road scenarios, being passenger vehicles. There would be the odd situation where a heavy vehicle might depart the road and strike the barrier and still hit the tree. If the barrier wasn't there, they'd probably hit the tree anyway. So in cases like this, putting a barrier in is generally better than not, but you need to take some steps to make sure that the installation is as good as it can be. Get it as far from the road as you can, subject to deflection, stiffen it up with reduced post spacings.
I think that stiffening up, Jamie, is a really important aspect if you do have a point source hazard like a tree or a power pole within areas that the barrier may deflect. Just because there is a chance of pocketing there, where you might be a little bit more likely to hit that tree just if the barrier is deflected and you get sort of drawn along into it in some situations. But the stiffening up of the system before that really gives it the it'll move the vehicle out before it finds that point source hazard. Yeah, so Lachlan, is that sort of giving you a bit of calibration? Jamie, actually, sorry, Lachlan, the one other thing, do you take into account the percentage of heavy vehicles when you're thinking about getting that roll allowance within working width?
Yes, you should. Well, certainly in the first place, the number and proportion of heavy vehicles might influence your barrier choice. You could argue here, this is a type B guard fence that's TL3 or TL2 even. So you wouldn't expect it to contain a heavy vehicle at all. So it's probably a bit of a nonsense to try and be designing for working width of a high vehicle. But certainly if you do have a high percentage and number of heavy vehicles, then it would be more of a consideration to get the barrier further away and design for your working width rather than just your dynamic deflection.
And if somebody's just asked, can they get the chainsaw out and lop those that branch off and a few other things, trim it up? Comments on that?
That'd fix the problem, but no, you can't.
Yeah, okay. Well, I suppose removing some of the trees, if you could, you were allowed to, would be a good option. But yeah, the challenges around native vegetation and the like can be trouble. And an arborist often says, big lopping off of major parts of trees is not a good thing. We've discovered in chatting to some of them. Okay, this is good, Jamie. We're getting lots of questions and comments and sites being put in. So I'm going to get you to move on with some of these because I want to allow a good bit of time at the end for you to talk to some specific questions.
So this is what we call a short radius curve treatment. And it is something that we can and still do even in high-speed environments. And it's something we do perhaps where we've got an intersection near to a bridge, or we've got an access point with a power pole or some other hazard very close to it, and we just can't fit a longitudinal barrier past. So we provide this sort of wraparound treatment. And if you look closely, you'll see that there's some timber posts with holes drilled to make them frangible. The idea with these type of treatments is that when an errant vehicle impacts sort of on the radius, the barrier, the posts yield, the timber posts yield, and the barrier sort of crumples in and brings the vehicle to a stop. To work effectively, you need this area to be clear of any hazards. So this looks like a situation where you can't fit a longitudinal barrier, but it's certainly not going to provide the full benefit of this type of treatment because you've got this cutting and trees and other things in that area that we need to keep clear. And the area that we're talking about is something like 5 by 7 metres in that order. There are Vic Roads standard drawings around this type of treatment that you can refer to. So it's because of the type of system that we're talking about, a semi-rigid one. It's not something you should do unless you have to. It's an option available to you in particularly constrained locations. Here we have it's a type B guard fence again, but it's located quite a long way from the edge of the traffic lane. It's beyond that 6 metres, which is now our desirable maximum offset. And in between the edge of the traffic lane, we've got curb, we've got a batter slope, which is nice and flat. It's probably drivable. Then we've got a table drain in front of the barrier and a change in grade. It's likely to affect a vehicle's trajectory before it hits that barrier. We have an increase in rollover risk because of the offset of the barrier from the edge of the road. So going forward, the preferred approach would be to locate your barrier somewhere up here. This is a non-approved product that made its way onto the Melbourne Road Network. I think it's called a Minnesota Bullnose, this one. Someone decided it would be a good idea to put this in. So I guess the message here is if you're approached by someone trying to sell you a barrier product, make sure it's on the the accepted products list for your jurisdiction. This one was, I think, subsequently assessed by VicRoads and not accepted, and the contractor was promptly asked to pull it out. Another situation where we don't have the space for deflection or working width that we would like. An attempt has been made to stiffen up the system by closing up the post spacings to probably 1 metre. So that's a good thing. Probably your choice of system is not the best one here. It's a built-up environment where speeds aren't particularly high. So there's a reduced need for that more flexible system, such as a wire rope. A guard fence product would have been a better choice because of its reduced deflection. Is that barrier better than nothing? I'd suggest it is. All of the other hazards in this area are further from the road. This is probably the odd one out. So on the whole, the barriers, it's a good thing, but the choice of system is probably not the best one. Here we have a guard fence at the roadside that's shielding some of the trees that you can see. There are certainly plenty of others that are exposed to errant vehicles. We certainly don't have the run out area that we'd like. Our 18 metres by 6 metres in this area. You might notice that we have a cut batter to the left of the image that sort of runs out just before the start of the barrier. This is a common situation where we have a barrier start at the transition from cut to fill. So desirably, this barrier would extend closer towards us to somewhere around here, but we perhaps can't extend it too much further because of this cut batter. But if it did extend to somewhere like here, it would shield a lot more of those trees. We'd have a nicer run out area. Perhaps it's started where it has to provide a maintenance access point at this area here. Here we've got a barrier in a narrow flush median. It's an extension median terminal, which is not a mash tested product, but as it stands, it's the only available median barrier terminal. So if you have a median situation where you need a median terminal, talk to the safe system engineering team, seek their advice. It's likely that they will suggest that you continue to use this product in the interim until we see a new median barrier system come onto the market. On these projects, there's been a real desire to squeeze things up and narrow the median to as little as possible. And this one's only 1.4 metres wide. The terminal is something like 800 mils wide. So you've got very little clearance on either side. It's a project that's been progressively upgraded in stages. And at the time this photo was taken, this was the first median terminal that you would have encountered. Shortly after its installation, it was struck by the Coles truck and flattened. And interestingly, it's always trucks, or most of the time it's trucks striking these median terminals. And a large reason for that is the amount of sway, the increased sort of trafficked width of a large truck.
Jamie, I've got a couple of questions for you, and the next slide actually probably answers one of them. So what you said, the only terminal for the central being the extension median, but that doesn't include wire rope. So that's only for
guard fence.
For guard fence. So there are wire rope systems, obviously. The next one was about use of a quad guard or crash cushion or crash attenuator in these medians. Wouldn't that be a better treatment? I'll start by saying that's a very expensive treatment. I mean, those things, clock in at somewhere in the 25,000 or plus at least, and your terminals are, well, more like 4,000 or something. But any other comments on the applicability of a crash cushion?
Yeah, the difference between a median terminal like the extension median terminal there and a crash cushion is that a median terminal like this can be struck from either side. Well, they're intended for median applications where there's traffic going in different directions on either side, as opposed to a crash cushion, which is typically located in a gore area where there's traffic travelling in only a single direction. So they can be struck from either side by traffic travelling in the same direction, so that they're not crash tested for that reverse direction. And I think depending on the product, there's perhaps a potential snagging risk if they were struck in that way.
Yeah. And another one, sorry, Jamie, and it's more probably back to the one where there was the sort of trees. The comment is you've got to draw a line somewhere, don't you? So, you know, you could just keep extending and extending and extending and extending the barrier. So any comment on how you make a determination of where that line is drawn?
Yeah, it's a good point. You really should be, the barrier in that instance appears to be there to shield those trees. So you need to provide an appropriate, or you should, if you can, provide an appropriate run out length in advance of those trees. You should also be thinking about run out areas. So that might influence where you start your barrier, to have a nice clear area of at least 18 metres length by 6 metres wide at your terminal. So, look, going forward, we're talking continuous installations. The entire roadside area is a hazard. Yeah, you could continue it as far as you like, and that would be providing additional benefit. Hazards like those trees and poles are, present a greater risk on the whole than your relatively flat batters. So if you can extend it to at least shield those hazards, you're doing most of the job.
Okay, thanks.
Another example of a median barrier being flattened before the project was even completed. In this case, we did have a wire rope, so no concerns there about choice of terminal. Relatively narrow system, so from that point of view, that's a good thing for a median application. There are different schools of thought about wire rope versus back-to-back guard fence in medians, and more often than not, we're sort of probably favouring the back-to-back guard fence at the moment, and that's in part due to its reduced whole of life costs, reduced maintenance requirements. The downside is the width of those terminals, the fact that when posts are knocked down, there might be associated pavement damage, as opposed to with a wire rope. There's a footing that in theory isn't damaged when the posts are knocked down. You can just pull out a damaged post and slot a new one in. The key at these median applications is to provide a high level of delineation and a consistent level of delineation. There's been a lot of learnings in this space in recent years, and here are some examples that we might see around the network. The example on the right is common in New South Wales. I'll show you some more photos. You can see there's a range of things that have been done to provide advanced warning, visual and tactile in some cases if you were to drive over these bollards, which extended 50, 100 metres in advance of the wire rope, you'd certainly know about it. But in the last year or two, Vic Roads has provided some really good guidance around delineating the starts of median barrier treatments in narrow flush medians, and that includes detail around delineation. The preference is to widen, flare out the roadway in advance, or flare out the median in advance of those barriers, and to provide an island if you can to reduce the likelihood of those median barriers being struck.
Jamie, while you're on that photo, just a random question from me. Over to the side there, you've got looks like an ET2000 and a sign, right? Looks like right up, tucked inside it. Is that frangible galvanized steel post going to compromise that, or is it, frangible and it's not really an issue at all?
Probably not going to affect the performance, but we can't be sure. So the preference would be to keep any of those sort of objects outside of that run out area, basically. That's an extruder type terminal. It's going to spit the rail out to the side. Look, there's probably a small chance that it could affect the performance of the terminal, but the safest thing to do would just be to locate it well away from that terminal, so there's no chance that it could affect its performance.
Thanks.
On the installation side of things, various things that can go wrong. Some of these can be attributed back to the design sometimes. And it's important that if an installer does encounter something that they think is going to be difficult to install or that's not going to provide a good barrier outcome, they put it back on the designer. Decisions shouldn't be made on the fly, on site. There are a range of considerations that a designer will have made, and it's important that if there's something encountered on site that means a change to a proposed barrier, it's fed back to the designer to get their thoughts and their sign off effectively to any change. What's happened here? Can anyone tell me?
Okay, pop it in the chat. First one to guess what's happened in the installation process. So I think Bilal's got it with hit rock. So the others were correct in saying it's supposed to obviously too high, footing's not deep enough, and the like. But the reasoning behind it, yes, was rock. So Bilal just in before some others who also put that in. Jamie, explain a little bit about what happens there.
Spot on. They've hit rock, and rather than drill into it as we should do, what have they done? Just cut off the post. So obviously those posts aren't embedded nearly to the depth that they should be, so the performance of that terminal is unknown.
Well, is that not just innovation, Jamie? Everybody's all about innovation these days, chopping the post off.
Well, that's one way to put it, but it's certainly not a configuration that the terminal is being crash tested in. So we just can't be sure of its performance.
Yep.
And there's that cut-off post.
So I suppose a question on that with surveillance officers and the like, people who are looking at these installations, they've cut that one off right at some points where you can see there's some oddness to it, but how would you tell if they were cut off without digging down?
Yeah, there are some telltale signs to keep your eyes out for. You can see these are all sort of fabricated components. There are holes at strategic locations that you can pick up, and depending on the system, there might be little chinks in the side of posts to weaken it at sort of strategic points. So it does depend on the system, and it might be that you couldn't tell unless you were there at the time whether that had been installed to the correct depth.
Okay, let's keep moving on.
Here we've got the X350 terminal. Again, it's not a MASH accepted product, but there are a lot of them out on the network, and there are a handful of key issues that you can that you might encounter with this particular terminal. It has the two cables running along the back, and in this instance you can see that they're quite slack. There's no particular tension requirement in them. These cables anchor to the ground at this end of the terminal, and then to the left of the picture they anchor again on the back of the rail. When the terminal is struck by a vehicle travelling from right to left, there's a locking bar inside the terminal head there that grips against that cable, and the tension at that connection brings the vehicle gradually to a stop. This one's obviously not as tight as it should be, and you can see it sort of visibly sagging below the bottom of the rail. So that's the telltale sign. If you can see that sagging below the bottom of the rail, it's not what it should be.
And we just got a comment in questioning whether that's Santa in the background. So random comments and questions there, but we're not doing a Santa count, we're doing a Wally count.
Good spotting. Again with the X350, this piece of the terminal, whoops, this component here is called the slider unit. And the idea with this particular barrier system is that when it's struck at the end, the rails, there's not a sort of a rigid connection between successive rails. They slide one over the other as the vehicle is brought to a stop. This piece here, this angle bar it's called, the intention of the angle bar is to knock out these black blocks on the posts as the rails do slide one over the other. This angle bar has been installed on the wrong side of that post and block. It should be over here. So this rail can sort of push over this one and knock all the blocks out of the way as it goes. So that just goes to show that the installer in this case didn't understand how that system works, and that's a very common issue with this particular product. This is a photo provided to me by Daniel Cassar, and he's very, very passionate about this one. This is a dodgy guard fence repair job. This is actually the site of a fatal crash where a four-wheel drive or an SUV penetrated the barrier and people were killed. The person charged with maintaining or repairing this barrier saw fit to just straighten out the posts at this location and stand the barrier back up. So that's a pretty ordinary effort when the barrier should have been replaced with new posts. Here we've got the ET2000 again. It's not a MASH accepted product. Can anyone spot the issue with this installation?
Okay. Bilal, you're going to be put out no prizes for you for this one because you're going to know this product intimately. But anybody else see an issue there? Pop it into the chat or the Q&A. People are madly typing. So W-beam hanging out of the gating terminal. So I think that's pretty much right, isn't it? Not going through the extruder. So yeah, Lachlan just in first there, and yeah, a few others there with some different ones. Some comments about the not having a chevron at the front, but I think that's a New South Wales one. They don't use a chevron at the front. They use that line. Is that right?
That's right. This is probably the standard sort of standard look of an ET2000. In Victoria, we use the motorcycle friendly cover with a chevron, black and white chevron on it, but one and the same terminal. And with this terminal and any extruder type terminal, probably the main issue that you can find is that the rail isn't inside that extruder head. So the likelihood is that if that terminal was struck end on, the rail would spear out to the side rather than get pushed through the head and extruded out to the side.
Yeah, Lots of correct answers there. It's just Lachlan got him first.
We have a rub rail that's inappropriately terminated or not terminated at all. We can install a little shroud on that to make it more forgiving in the event that someone, perhaps a motorcyclist sliding along the road, strikes it. Here we have a terminal, an extruder type terminal that's been concreted into the ground. So that's not going to budge when it's hit. Our guidelines say that the maximum number of blocks that we should use on a guard fence is 2. Here we're up to about 5. Obviously we've got services in the mix, and the posts had to be installed well back from the rail position. Will this perform well? Who knows? Maybe there's an increased likelihood that if a vehicle impacted that rail and the posts rotate back, the rail height will increase and it may not perform particularly well. Wherever possible, maximum number of blocks at 2. But again, this is a type B installation, which we're not going to see a lot of going forward.
What would some other options be there, Jamie? Because we've got a comment that's come in as well. Is that not the best that they could do in the situation with the services and the like?
Yeah, we might be able to use a bolt down post, and the proprietary products generally have a bolt down option. So if we could create some sort of concrete footing and bolt our posts to that, that's subject to the depth of the services at that location. And another alternative it's a bit hard to tell from that picture what's happening. We've got a path there, perhaps our barrier at back of curb might have been an option there.
Yep.
Here's a bit of a dodgy install. Not quite sure what's happening here with this cable over the top. Yeah, pieces not connected. Not good. Barrier height is one that comes up a bit. The height of barrier installations has increased in recent years. The standard height of guard fence increased a number of years ago by about 50 mil. You can see in this picture, this one's as low as 600 mil. All of the new wire rope products, the mesh wire ropes, have increased in height to ensure that they can contain the larger vehicles that they're now tested to. So be mindful of barrier height. If you have a guard fence installation and you need to raise its height, you can use an Abraham block in the case of type B guard fence, and the suppliers of proprietary products have their own versions of that for their particular product as well. That's a little alternative to the standard block that can be fitted to existing posts to raise the height of the rail by something in the order of 100 to 200 mil. This is a site in New South Wales that we investigated. It was the site of another fatal run-off-road crash where a vehicle penetrated the barrier. Again, it was a four-wheel drive or an SUV, and you can see that barrier looks particularly low, and that's at least in part due to the build-up of all this material in front of it. So we measured the height of that one, I think at perhaps even a little less than 600 mil, when it should have been more like 750. Anyone spot the issue with this installation?
Oh, this is a little bit of a more challenging one, I think. Let's see what comes in. Oh, Sam, straight off the bat. Oh, they're coming in thick and fast correctly. So curved terminal, I assume, is the one you want to point out there.
That's the big one.
Well done, Sam. That's your prize, and thanks to the others who have got it correct.
Any great must be installed perfectly straight to ensure that it will perform as it should. There are often tricky situations on curved roadways where it may not be easy to achieve that, or it might seem like the right thing to do to curve it, but we can't be sure of the performance of that terminal.
So Jamie, you say that it can't be curved, but you talked about flaring. What's sort of the difference there?
Yeah, so a flare is basically an offsetting the head of the terminal by a certain amount relative to the sort of subsequent or parallel section of the barrier. Where we provide a flare, the terminal itself is perfectly straight, and we basically, the next rail after the terminal, we install a bit of a radius or a kink to change the angle of the terminal and flare it away from the road by about 600 mil, as opposed to creating a curve within the length of the terminal, as you can see here. Another thing I'll point out, if you look close at this connection here between the rails, you can actually see the rail sort of sitting out from the rail under it because of that curve. The guidance certainly in Victoria, and I think now in New South Wales, is that for any grate, the rail overlap should be for the direction heading away from the impact head, if that makes sense. So the first rail should be located on top of the next rail, which should be on top of the next rail. There's been some confusion in the past about that, and that confusion is because a lot of people think that you should overlap the rails for the direction of travel for the nearest traffic lane, and that overlap direction should continue right to the through to the departure end terminal. I hope that makes sense. But to ensure the performance of the terminal, we need to assume that it might be struck end on and the rails need to be overlapped accordingly.
So Jamie, questions come in. If you can't fit the straight terminal, is curving it like this the next best option, or?
Probably not. If you might look to extend your barrier a little further or terminate it in a slightly different location to ensure that you've got that that straight alignment. I'll point out that this particular terminal is the test level 2 variant, which is appropriate for lower speeds up to 70 k's per hour, and it's quite a bit shorter. It's sort of in the order of, well, the new MASH ones are something like 9 meters as opposed to 16 meters. So if you're on a curved roadway, chances are your speeds are not particularly high, and you might get away with this test level 2 variant. So that should make it easier to achieve a straight terminal than using the longer version. Look, I'd encourage you not to curve a terminal at all. If it's absolutely avoidable for some reason, minimize the amount of curvature as much as possible. Some more installation issues. This wire rope anchor block is obviously lifting up for whatever reason. Perhaps it hasn't been installed to the size and depth that it should have been. And that actually is something that I've encountered quite a lot on site. There are typical details for these anchor blocks, and they're particularly big lumps of concrete. So if something like this is happening, perhaps it hasn't been constructed to the correct size, or the ground conditions aren't what was expected, and an alternative design should have been used. This is the X350 terminal again, and this is looking down on the impact head. I'll point out again, this is a non-accepted product for future use, but there are a lot of them out there on the network. And this is one of the issues that does commonly arise with this product. If you look closely at the image on the left, you might see a cable inside, and that's the cable that we saw the side-on view of earlier that runs from the ground to the end of the terminal. This system works by rotating this locking bar, vertical locking bar, to this position. And the result is that the cable that passes through holes in that bar is kinked at this point. So any vehicle that impacts the end of the terminal causes the terminal to push along that cable, and there's a lot of friction developed at this point where the cable kinks through this locking bar. In this case, the cable is dead straight. There's going to be no resistance whatsoever. So that terminal is just not going to perform. So that's one of the key things to look out for with the X350. Another example of a wire rope footing. It's a no longer accepted type of terminal or wire rope system, an old footing, but same issue. Again, this is a smaller footing than we should have. I do encourage you to check the dimensions of the footing for the system that you're using, and to be mindful of those on site if you're inspecting an installation. It's not uncommon for them to be installed to different sizes, and that might be because of some constraint on the site that means that you can't install it in the way that you would want to. Where that's the case, I encourage you to consult the product supplier. It may not be the case that you have to install the footing to the exact dimensions that are specified. The suppliers can help you by designing an alternative footing. It might be that you've got services at a particular depth that mean that you can't install the footing as deep as you would like. So you might install a shallower footing that has a bigger, that's wider and longer and has the same or greater mass and will still perform. So talk to your suppliers about that where you've got constraints like underground services. This is a bad example of an intermediate terminal or an overlap of terminals. It's a non-accepted product. This is an anchor point for a terminal. This is another anchor point. Slight overlap between the two systems. No space between them for deflection. Each of the suppliers provide a typical detail for what we call intermediate terminals, where successive barriers are overlapped, and this certainly isn't in accordance with those. For any wire rope terminal, the cable should be anchored centrally within the block. You can see here that these cables are off to the side of the block, and that's something that's relatively commonly done where you've got a wire rope behind curb. So it's understandable that an installer would do that because they want to sort of maintain a straight alignment as much as they can rather than to kink it away from the curb at the terminal. But this is not by the book. Within the anchor, there is some reinforcement, a reinforcement cage that requires a certain amount of cover. So it may not be the case that the adequate cover is provided here. Can anyone spot the issue with this installation?
Okay, I'm going to give that one to Trevor for different posts, which I would, we'll use different systems really there.
That's right, we've got two different systems, good spotting. In the foreground, we've got the old Bryphon system, not to be confused with the new MASH Bryphon system that's available, connecting to a flex fence system. So I'm not sure what happened there, whether they just had a few Bryphon posts in the back of the ute or what happened. But certainly we shouldn't be mixing and matching systems. The performance, particularly at this transition point, is unknown.
Well, Jamie, this actually covers off a question that's come in, or a comment that's come in. So many systems and, systems that are legacy now and redundant, and then is this not just a maintenance headache? I mean, personally, we play a little bit of barrier bingo these days because there's that many barrier products and systems out there that we have some good fun with trying to spot them all and tick them off your list. What are your comments around that?
It's a good point. Going forward, there's going to be a lot more systems out on the network. It is a good question. It does complicate things from a maintenance point of view.
I
was just
going to say, I suppose that to me is a little bit of consideration in the design also, where if you can match with existing systems in the area, it can be something that you take into account really to try to minimize the impact on the maintenance crews.
Yeah, that's right. And in general, we don't like to nominate particular systems because the different competing systems are all crash tested to the same requirements. But one instance where we might want to is particularly in more isolated locations where we have a certain system in use and we'd like to continue to use the same one.
And also, I suppose Evan did mention in his presentation that the acceptance at a jurisdictional level of additional products, one of their factors is how many of these have we got already that achieve the purpose that this new one is coming along. So it's a little bit factored in, but I do tend to agree with that, and it is just a constant challenge to keep up to date with the new systems, the alterations, what's happening with different existing systems. So you've got to really keep on your game here and read those road design notes as they come out and keep checking the jurisdictional websites for what's current. And partly that was why we had that assignment for you where you took just one product just to go through that process. Well, it should be sort of that with other products as you go.
Wire rope foundation at a terminal. This little piece here, this little fin, is basically an installation guide. It should be installed flush and level with the concrete surface. Here it's obviously protruding quite a bit, and it's angled back such that these teeth are near vertical, and there's an increased likelihood that these cables might pop out the top when the system's impacted. So desirably, this whole anchor bracket would be sort of rotated down so that fin is horizontal. Wire rope located right at the hinge point, pretty much. Two issues there. We don't have, we're not containing any of the deflection of this system within the verge. So there's a likelihood that an impacting vehicle will end up going under the barrier and coming to grief. We also have very little structural support for those posts, and you can see already that there's a bit of erosion happening around those posts. There's a bit of a makeshift attempt to repair a damaged barrier that's certainly not going to hold up under any sort of impact. This is a little further up the road to the photo I showed with the wire ropes at the hinge point. Again, wire rope at the hinge point. The drainage here, some widening took place. Perhaps there was inadequate compaction. There was a particularly heavy rainfall event after this these works were completed. So it was a bit of a perfect storm that resulted in a lot of undermining of the existing barrier systems. So you can see here, the block is protruding quite a bit, and we can't be sure that it will perform as intended. Barrier height is typically more of an issue for guard fence than wire rope, but something I do commonly find is wire rope post footings that are mounted up excessively. You can see here with our little high-tech measuring device, the cable should be located at the black lines within the pink tape. So we're sitting perhaps 70 mil or thereabouts higher than we should. Now, barriers being too low is generally the issue, but a barrier can be too high as well, and the risk there is that a smaller vehicle might underrun the system. So our post footings should be constructed so that water sheds away from the post hole, but certainly not built up excessively like this one is. This is a wire rope tension bay or turnbuckle arrangement where the system can be tensioned or detensioned. And these systems do need to have their tension checked on a regular basis. You can see at the top cable, the threads pretty much touching. There's no scope to further tension that. Desirably, we'd have a small amount of thread showing on each of these cable ends, which would allow the system to be tensioned further over time and perhaps detensioned a little if need be. Perhaps if there was a vehicle impacting and we wanted to remove a bit of tension. Drainage structures often present some challenges, and you can see here we had very little verge in which to embed some posts. This guy is sitting somewhere on top of or perhaps between those drainage units. Hard to see. Here, there's a hidden culvert and the post was tapped directly into it. So be mindful of where your drainage structures are. Locate your posts to straddle smaller culverts like this. In the case of a bigger culvert like this, you might want to omit a post and straddle over the whole thing if you can, if it's not particularly wide. But if you're doing that, you need to think about compensating for deflection at that location by maybe double nesting the system if it's a type B. So double nesting is sitting one rail over the top of another, which we can do with type B installations, not with the proprietary products. The other thing we can do is close up our post spacings before and after that culvert to reduce its deflection. So you can see here we've got a culvert or a bank of culverts that we've straddled. If you look very closely, you'll see that this rail is double nested over this length to stiffen it up. And obviously we've got those reduced post spacings. So this, by doing that, we've sort of compensated for omitting that post in terms of deflection. Temporary barriers present a different list of challenges, and a lot of them depend on the particular system that you're using, the connections between them, whether there are water or not in the appropriate units and so on. I'll show you some examples. It's often the case in inner city locations that barriers are used for reasons other than roadside safety. Here we can see a ladder leading up to the top of this installation, a bit of a walkway along the top. Certainly you'd be taking your life into your own hands using that. Sometimes we see add-ons to the top of barriers, screens to stop debris. and the like. This is not an accepted configuration and should be avoided. Use the barrier for the purpose of shielding the roadside, not for other purposes. Here we have a temporary barrier sitting at the side of the road with an exposed end that's a hazard to an errant vehicle. No terminal applied there. It's sometimes the case that temporary units are used as delineation devices. These are obviously not linked up. They're not going to provide any benefit in terms of shielding pedestrians at the roadside or containing an errant vehicle. This temporary barrier has been flared outside the old 9-metre clear zone. That was something that was accepted in the past. It certainly is not anymore. The exposed end of this concrete terminal is a significant hazard to anyone leaving the road at this location. You can see a wire rope nearer to the other carriageway. It's perhaps the presence of that barrier increases the likelihood of someone striking this end by capturing them and redirecting them towards it. So that should be appropriately terminated with an accepted temporary barrier end terminal. System here sitting in front of concrete, it's likely to deflect if a vehicle strikes upstream of that concrete and perhaps still present a snagging hazard at the concrete there. That's an innovative use of concrete units, I'll give them that. Not doing much in terms of road safety benefit. One thing they have done is put some bollards at strategic locations in an attempt to shield the column here, but really it's not doing a lot in terms of shielding that scaffold. Another exposed end of a concrete temporary barrier, highly constrained location, not the space to put on an appropriate end treatment, and in an attempt to do something, a couple of energy absorbing bollards have been put in front. So credit for doing something. Maybe the locations of those could be improved a little bit. Maybe push one over here to better shield that end.
I mean, do you just want to, I suppose, cover what that energy absorbing bollard is for those who may not be familiar with those? They're not just a concreted in bollard, are they?
They're not. They have sorry, Ken.
Oh, it's like a cartridge, isn't it?
Cartridge. Yeah, they have a cartridge beneath the ground that's sort of sacrificial. When they're struck, there's scope for that bollard to sort of rotate about its base within that cartridge. So they do provide some, they have some ability to contain errant vehicles. So that they are a road safety device or road safety barrier of sorts. There is a Vic Roads road design note that deals with energy absorbing bollards.
And are they acceptable instead of an end treatment?
An end treatment is always preferred. They're typically used at locations where we've got low speeds, perhaps locations where we've got some curbside dining or something like that. They can be used as a bit of a delineation device to stop people sort of encroaching the curb when they're parking and this type of thing, and also provide that benefit of containing errant vehicles. Yeah,
and we're getting some commentary that people are okay with this in those low speed environments, as you said, Jamie.
That's the key, low speed, and where you don't have the space to provide a longitudinal system, you can provide one of these or an array of these to stop vehicles from encroaching, particularly pedestrian areas.
And I have seen in the latest Victorian road design note some other variations on these short end things. I don't know if you're going to cover that.
I didn't have any more on that, Ken. No.
Okay, I might bring that up. I'll dig it out and pop it up if we get time. But we've got a good few live examples to cover after you get through these.
Temporary barrier there between the traffic lane and a pedestrian walkway. Remember that these things deflect quite a bit if and when they're struck, and would certainly deflect into that pedestrian area. As has happened here. So fortunately, there were no pedestrians in that area when that was struck, but there is potential for that to happen. You need to be mindful of not encouraging pedestrian activity within the deflection zones of these systems. That's a bit of a mishmash of different products and systems. We've got a permanent, sort of a variation of an ET2000 terminal tacked onto a temporary concrete barrier. We've got a timber sort of debris or gawk screen on the top. So that's a real mix of things that's serving a purpose, but we can't be sure if that will perform well from a road safety point of view if it's struck end on. No approach length or run out length provided in advance of that scaffold. Desirably, that barrier would extend quite a bit further towards us to adequately shield that work area. And as with permanent systems, we need to be mindful of providing run out areas at temporary systems. Scaffold connected directly to a temporary system again, that's a no-no. That barrier system at face value or from this angle, I can't fault it. From a different angle, you can see that the barrier is pretty much right at the top of that vertical drop. There's no space. No space has been allowed there for deflection, and an impacting vehicle is likely to push the barrier over the edge and end up over the edge itself. So there are a few things happening to try and reduce the instance of installation issues in particular and design issues. Certificates of compliance, that's a system that was introduced in 2012, and that required the suppliers of proprietary products to basically warrant their products have been installed correctly. The way they've gone about things is sort of evolved and improved over time, and they've got some great systems, some apps that they use these days where photos are taken of particular points of interest of each terminal in particular. That's where most of the issues have happened with proprietary terminals, but also the longitudinal barriers need to be assessed to ensure that they have been installed in accordance with the supplier's requirements. National Safety Barrier Industry Accreditation. There's an accreditation project in the pipeline that'll be run by a UK company called Lantra. And through that program, designers, installers and maintainers of barrier systems will need to be accredited to install products, and they'll need to have specific accreditation for each of the proprietary products if they're installing them. So stay tuned for that. There are a number of different levels of training and accreditation, right from sort of labourer level through to the lead installer and also for designers. Well, there is an excerpt from one of the VicRoads standard sections around compliance auditing of wire rope systems. There's a similar clause in the guard fence section, specification section, and the requirement is that the supplier or their representative provides a letter effectively certifying that their installations have been installed correctly, or reporting on any deficiencies which would then need to be corrected. So lots of good reference tools out there. VicRoads has lots of standard drawings and design guidance, which we've stepped through over the last week. They're your primary references along with the Austroads guide from a design point of view. if you're installing or maintaining barriers, I encourage you to look to the flexible safety barrier installation and maintenance guidelines, which you can see an image of there. It's a VicRoads document that is, I'm not entirely sure of its status. I don't think it's available at the website, but it is commonly used within the organisation. It's got lots of good stuff in there. You'll actually see quite a number of the photos that we've seen today in that document. So it really does bring together a lot of those key real world examples of things that that you might encounter.
And I think we've put that into Schoology and on your memory stick. And if we haven't, I'll make sure it's emailed out to everybody so you can have a copy.
Also got some images there of some product manuals that the suppliers of proprietary products put out. You can find them at their respective websites. They don't include everything. There's often some additional crash testing and the like that the suppliers have carried out, and they don't publish all of those results. Things around, deflections that reduce post spacings or speeds other than the typical crash test conditions. So if you've got a particular location that's constrained, I encourage you to talk to the suppliers and get their views. They may be able to give you some additional guidance. If you've got limited depth to play with and you need to provide a wire rope footing that's shallower than the standard, talk to them. If you've got not enough room for deflection, all these type of things, get in touch with your supplier. All right, at that point, I'm happy to take any questions. And then I guess Ken will step into some of these tricky examples that have been sent through.
Yeah, so Jamie, if you maybe stop sharing yours, I'll ask you a question and then I'm going to bring up a couple of things on my computer, which is the collection of sites and challenges people have sent in. One of the questions was around these temporary barrier systems and the deflection into pedestrian areas where you showed those couple of photos. Would it be better not to have a barrier system in those situations if you've got pedestrians behind it, or what's the deal there?
Yeah, good question. It's another one of those ones where is it better than doing nothing. The ideal situation would be to designate an area that pedestrians aren't to go in. How you achieve that, it's probably a case-by-case situation. Have the pedestrians walk some distance away from the barrier. But as we find, it's typically those really constrained locations that an attempt is done to do something. And it probably is better than doing nothing.
Yeah. I was just looking in at that existing road design note, added this thing, which seems to be another option, which is accepted for trial, the pole tree buffer. So something to keep in mind, and it's probably a good reminder. And there's the energy absorbing bollard, but it's probably a reminder to always, look at that road design note because things pop in there, new things at different points in time. So always download the one from the website rather than going to the one you've got you downloaded a few years back because things change. So I'll stop sharing that and I'll bring up a couple of live examples. So we've got about half an hour to go, Jamie. So we'll try and move through the ones that have come in, and if anybody else has any that come in later on, we'll talk to that. So now I'm not sure, Jamie, which you're seeing there.
Yeah, I'm seeing the barrier terminating at the signals there.
Yeah, okay, so this is the one from Sydney, as I understand. So we've got that part of it, and there's another bit of it. So tipping this one isn't a MASH compliant system.
I think you're right.
And so what would you be sort of thinking in these sorts of scenarios, Jamie?
Now, I understand it's a 50 km/h environment. It appears to me to be more of a device to funnel pedestrians than anything else. There's no obvious signs that it's been struck. So I guess on one hand, it's probably debatable whether or not we need a road safety barrier at all. If you were to provide one, you need to be mindful of minimum length requirements. It is a low-speed environment, so you could get away with a relatively short terminal, a TL2 grate. That would help in terms of achieving your minimum lengths. At the departure end, near the signals, we've got a few other things that are potential hazards. So we always like to provide grates where a terminal can be struck end on, but if we were to do that, again, we need to be mindful of those, of being able to fit in 2 grates plus some sort of length in between. And the fact that there are other hazards that would likely be struck before or in conjunction with that end terminal probably means that a terminal other than a grate, it might be reasonable to provide one of those there.
The very keen eyes of our participants, Jamie, have noticed that down the bottom here, it looks like a redo of the concrete, which potentially may indicate a hit.
Yeah, you're right. I take it back.
Yeah.
So you would need to have a good think about the history of this site, what the likelihood of a vehicle departing the road here is in making that decision around whether a road safety barrier is warranted. An alternative may be to install a pedestrian fence. If you do provide a road safety barrier, how do you mount it? You're going to need some sort of bolt down system. So yeah, it's a good one. Someone suggested that could be concrete cancer.
Down here, yeah, lots of thinking. So Jamie, you talked about the alternative of pedestrian something. What are you talking about there? Pedestrian fencing or?
Pedestrian fencing. So a fence that would not be intended to contain an errant vehicle, but would ensure that pedestrians stick to the path rather than jaywalking across the road at this location.
Right. And are there approved pedestrian fences that don't pose hazards to vehicles in terms of spearing hazards and the like, if they were to come off and strike here?
Yeah, each jurisdiction typically has a number of different options and standard drawings for fence types. You would need to be mindful that your fence didn't have horizontal members that could spear into an impacting vehicle. So some sort of weld mesh fence would be typical.
Very good. Okay, so again, there's a bit of there'd be a bit more work to be done in understanding the context and a bit of design work to be done there. Let's go back to beautiful Tasmania, and here's a what's this look like? A narrow road. I forget what the speed was in there, but what are your thoughts here, Jamie? Barrier, no barrier, other alternatives? And if you're going a barrier, what are you thinking in terms of types of barrier system, where you'd locate it?
Yeah, it's obviously quite a significant drop there that I suggest would warrant a barrier. The seal width appears to be quite narrow. So if any barrier went in there, we'd want to maximise its offset from the road so we're not narrowing things up further. We want to maintain enough width for vehicles to pass each other. The barrier solution that I'd suggest there would be a flexible W-beam, and that's because they can be located particularly close to the hinge point, only about 300 mil, and the system width is quite narrow as well. So you'd be locating that barrier as close to the hinge point as you can, say 300 mil. Because of the drop, you'd want to think about installing longer posts to ensure that it had adequate lateral support to the posts.
And are those longer posts something that are available off the shelf, or?
They are, yeah. I believe each of the suppliers of proprietary products has a longer post variant for the flexible W-beam products.
And in terms of terminals at this location, is there anything that would factor into your consideration about either choice of terminal or how it would be located?
I'd want to be providing grates on either end. You would try and find a location for those that were sort of least vulnerable to people running off the road. So away from curves. If you had a location where there was a wider verge that would allow you to flare the terminal, that would be great. Certainly you wouldn't want to locate the terminals within curves or anything like that.
So you mentioned earlier that the grade terminals have options, or they're crash tested, and there's different lengths associated with some of the test levels of the terminals themselves, and so you can go shorter with different. Where do you find that information?
You can look to the detail sheets or the technical conditions of use that Austroads publish. That's got a lot of good summary information, including the lengths of each system, their deflections, points of need, and that type of thing. So look to the detail sheets or equivalent in your jurisdiction. You can also look to the suppliers' websites and their product manuals, which spell out those things.
And so if you have a lower, like a test level 2 grade terminal, like how do you make that choice that it's acceptable to use that lower test level as compared to the higher one? So take, for example, this road, it's probably a default 100 km/h speed zone. How are you making that judgment call?
You need to look at your actual operating speeds on site, not which may be quite different to your posted speed limit. So if you've got any speed data, that might assist you. And of course, test level 2 is up to 70 km/h. If your actual operating speeds are no greater than that, I suggest you consider a TL2 product because they're cheaper, more easy to apply in constrained locations, especially on a curved road like this.
And if the operating speed was a bit higher than that, say 80 or the like, but you just cannot fit the full one, would you opt for that lower one, or would you? How would you handle that?
Yeah, look, it's very much a case-by-case situation. You may look to extend your barrier to a location where you can fit that. That would be the preference. And I encourage you all to always err on the side of caution and go to a test level 3 rather than a test level 2 if you're sort of at that borderline speed mark. So look, if that's all you could do, you could put in a test level 2 and that's all you can do. But there are a lot of steps that I'd suggest you go through before you get to that point.
So another one on this, I better be wary of time here. Just there's got to be hundreds of thousands of kilometres of this type of road across Australia and New Zealand. I mean, well, how do we pick where the barriers go? I mean, we can't afford to put barriers on all these types of locations.
Yeah, there's a number of ways you can go about it, and the update to Part 6. We discussed the NRRIT thresholds. You can use that process to assess the risk of this particular road based on its alignment, speeds, volumes, hazard offset, all of those things that we talked about. You might then be able to compare that to other roads that you might be considering treating. In the past, we've typically used reactive methods based on crash issue. crash history. So obviously, if you had a history of crashes here versus a location that didn't have that crash history, you would look to treat this one.
Yeah, thanks, Jamie. And I do encourage everybody to have a look at the recently released Australia's Guide to Road Design Part 6, which tries to sort of tackle some of these challenges. Okay, let's jump to another site, and please keep your comments coming in the chat, or if you've got different information about some of these or opinions, we're happy to share those with others. So what do we got here? We're down Skeens Creek Road, and we've got some newly installed barrier system. And if I remember correctly, and Jamie, you'll remember, there's access required at this point up here to get to something. I'm not sure what.
Yeah, there supposedly is an access point that needs to be maintained at this location to access a power pole that's approximately 100 metres through the bush. So firstly, it amazes me that any sort of vehicle would be able to get through there, but on the assumption that we do need to provide an opening, there's not a lot you can do. Basically, you're going to need to create an opening with terminals on either side of an appropriate width that can accommodate the swept paths of any vehicle that needs to turn in there. As part of doing that, I'd suggest that you flare the downstream barrier. So this, thinking about the direction of travel closest to the barrier, flare the downs.
Oh, I missed that. Yeah. So keep talking, Jamie.
So for traffic in the lane adjacent to the barrier, flare the terminal on the downstream side so that it's somewhat shielded by the upstream barrier. That is sort of the typical approach. You do need to think, though, about the geometry of each approach to the intersection and where vehicles are likely to depart the road. And I did have a bit of a look at the crash history along this road, which is high. None at this particular curve, but quite a number in the vicinity. And interestingly, most of those crashes, or all of the runoff road crashes at curves, involve someone leaving the road on a right-hand bend. So that would be the direction of travel coming towards us, and that would support overlapping the barrier in the way that we talked about with the downstream barrier flared in behind.
Yeah, it's very hard to draw on this one, and but that's trying to give you that idea. And obviously, there's a lot of details to work through in that actual design and the site. But yeah, and each of these terminals you mentioned, Jamie, are they going to have to be great terminals as well?
Yeah, they'll both need to be grates, and they'll need to be straight, unless by some miracle we can tuck the downstream barrier in behind, such that it can't be struck by an oncoming vehicle. Then we could get away with putting a trailing terminal at that end, but I don't expect that's the case. We've got pretty limited width to play with. I expect that terminal on the downstream barrier is going to be exposed to oncoming traffic, so we'd need two grates.
Good. Feel free if anybody else out there has other ideas on how to address these things, or has other considerations or factors. But again, these real world sort of challenges and getting out there and stomping on the ground and having a real look at it is really the way to do it. It's always a little bit harder from these from pictures and the like. Yeah, that's going to be a challenge. What do we got? This one just came in from the Lilydale, Mount Evelyn area, I think, and it was just, I think, now I can't even remember who popped this in, but feel free to unmute yourself. I'm actually just going to go to the street view on that one, I think, instead of sorry, bear with me, Jamie. I just want to No, I don't have the street view of it up and running. So we'll go back to that. It's a replacement, I believe, was the requirement, and we've got some significant services in the area. Any comments on that? So this is just the exit of a roundabout.
Okay, it's I can see that the terminal is a non-accepted product, so you'd want to look to install a grate. If it's the departure from a roundabout, your speeds are going to be relatively low. You'd get away with that TL2. I can see we've got barrier curb at play there too. So by the book, we should be locating that rail in line with the face of the curb rather than some distance behind. It looks like the barrier might be just located a little behind. The trade-off with that is that it can be more prone to nuisance impacts. But locating it in line with the curb is about minimising the likelihood of someone vaulting over the barrier. So in this case, great terminal. Because of the speeds, we could use a Type B or a proprietary product. I do want to make the point, I'm not sure if we've made this point before, but we have three main suppliers. Each of those has a flexible WM product and a terminal. You must use the corresponding terminal and longitudinal product at the moment, which hasn't sort of been the case in the past, but that is that's the current preference.
So Matthew, you should be able to unmute yourself now. Sorry, I was a little slow on finding you there. So if you click unmute, you can just have a chat if there's something you wanted to add there. Hopefully you can unmute yourself.
Hi, can you hear me?
Yes, loud and clear.
So when this barrier got hit, there's about that second post in was a 2 metre diameter Melbourne water pipe running down from Yarra Ranges. And to just try and fit it back, like the new terminal, which are sort of 15 metres long, this angle doesn't really show it, but it's on a bit of an angle. And so just to achieve that straight, the other issue was at the time there was no base plate variant for the new terminals from the X350.
Right. Now, is Google coming up there, Jamie, or are you still seeing that?
Yeah, I've got Google now. Yep.
All right. Let's have a bit of a look from over here. This might help us out a little bit, I think, Matthew. Is that you've got big service issues in here, eh?
Yeah.
Okay, Jamie. I'll
well,
go back.
My question is, does the barrier need to extend as far as it does? There's obviously a power pole further along that it would be nice to shield. I wonder why that barrier is there, if there's been someone sort of speared off the back of the curve and gone through the fence there, but there are no other obvious hazards.
Yeah, I think from memory, when it got hit, the person living there wanted it put back because it protects their house.
So Jamie, the comments about, was it flared quite far back, was it, and around, or?
I'm just looking to the power pole there, which perhaps the barrier doesn't even extend to shield fully. If the issue is the services, you mentioned bolt down variants, it might be necessary to use a bolt down option. If it's a sort of a transverse service that we can straddle, we might want to fiddle our post spacings to do that. If it's within the terminal length though, that's not something we can do. And you'd want to look to a terminal with a bolt down arrangement.
Yeah, that was the issue with the terminal being where the services were, so you couldn't space the posts
Right.
out.
So just, sorry to say on this one. So Matthew, is the service sort of going that way? Oh, you're on mute again. You're on mute there, Matthew.
Oh, sorry. Yeah, service runs sort of perpendicular to the road.
Okay. Challenge there for you, Jamie. Move it
Certainly
back.
is.
Start it back here.
Yeah. Yep. And that being a breakaway terminal, it appears to be. The breakaway cable terminal A types, and it's a bit hard to tell what that is, at 10 metres long, and they're fully gating. So that first 10 metres of a BCTA is ineffective in capturing an errant vehicle. So if you were to suppose you were to replace this terminal with a grate that started a few metres past where this barrier currently does, it may not be any worse in terms of its point of need location and its ability to redirect errant vehicles.
I suppose there's a slight perception challenge there with the resident there who would not understand the technical intricacies probably. And I wonder whether there's some sort of bollard, you know, back near their house line for some of that may alleviate a little bit of that concern. So some energy absorbing bollards or something, not the ideal solution, but maybe something. We got one more to cover. So Matthew, I hope you got a few little insights, but this goes for Matthew, but for others as well. You always welcome to have some one-on-one chats with Jamie after this about these sort of sites as well. I'll just try to get to this last one as well. And again, another one that's come in just recently, and I can't remember who put that one in, but pop your hand up and I can unmute you. But it looks like the barrier going in, the curved bit of road, so like a modified T. Here we go, Adam, thank you. I'm going to let you explain exactly what's going on here. So hopefully just unmute yourself now and you should be able to talk.
Can you hear me now?
Yeah, just speak up a little bit.
How about now?
Yep.
Yep.
Oh no, you're very weak there. It's quiet. I can't quite hear you, Adam. No.
No.
Oh no, that's it. Yep.
Oh, yeah, there? Yep. Easy. So yeah, at the moment we've got concrete barriers that are turning around the outside of that curve. And we've got a work site which we're wanting to provide an access point to just outside the curve. And in order to provide the appropriate
Jamie, did you catch that?
I can't hear, Ken.
Yeah, no, it's sorry, we can't hear you there, Adam. I'm not sure what's going on with your microphone, so we might have to give you a second to try and work that out. I've got another hand up here somewhere. No. Try again there, Adam.
sorry, can you hear this?
Yep.
Yeah.
Yep.
Alternatively, do you want me to type the explanation?
No, it just drops away once you start talking. We can't capture that one. You could jot something into the chat as we go. I'm going to go back to the chat and just type it in. Jamie, you read that while we go. And yeah, we've got a few people who are saying they can't hear that as well. We've only got a couple of minutes left. So urban environments are different to rural, even through the tree and car. Houses are private properties, clearly inside the area of interest. Why not consider a hazard very interesting. And then yes, we can't hear. So yeah, I mean the urban areas are a very challenging environment, as Jamie mentioned earlier, and you've got many sort of constraints and sort of the barrier designs that Jamie and his team do when they come in. Those sort of big open freeway designs are a lot easier in terms of most of it than the constrained urban environment challenges. So you've got to do them case by case. And
questions there, yeah, around urban environments and area of interest. Certainly urban areas are very different. We have all sorts of things located close to the road, like poles, traffic signal pedestals and the like. Because of the relatively low speed environment, they're typically not significant hazards, even though they are within that area of interest. It's unusual to see barriers in urban environments where the speeds are generally less than 70 kilometres per hour. We do see that handful of locations, such as around roundabouts, and locations where we at curves and where we particularly want to stop an errant vehicle running off the road. Yeah, the risk on the whole is reduced for the occupants of those errant vehicles. It's often more where there are vulnerable users near the road that will see a barrier.
Okay, Jamie, I'll let you just read what Adam's popped in there now for some final commentary on this one. We've only got a few minutes to go. As Jamie's reading that, I just want to mention to everybody, I have mentioned a day 2 and 3 for this course. So this course is the fundamentals course. So we're trying to give everybody this good grounding on understanding road safety barriers, what happens in different jurisdictions. It's a sort of fundamentals, and then delving into a few of these issues. And it is a course in its own right. You'll still get a certificate from this course. The day 2 and 3 are called the applications. And this is where we delve into a lot of these sorts of challenges. We give you these challenges to work through in terms of design, choices, and those sorts of things. And we give you a live site to go and do a design with lots of these real world constraints. So we can't run that one, or we don't run that one as an online. It's an in-person workshop, but we will be providing you all with information about that once we are in a position to be able to set a date to actually physically be in the same space with people, which is looking a lot better with how we're going. Now, Jamie, did you have any quick commentary on this one from Adam and from what has been said there?
Yeah, hi Adam. It looks like you're thinking about all the right things, and you've, yeah, doing a few things to address the risk. We're changing priority at this location, and the work site is going to be on Mackenzie Road there, which is sort of previously the priority route. So, I agree, there is a risk that vehicles may inadvertently continue into there. As far as barriers go, putting the quad guard at the end of your barrier B3 sounds like a good idea.
That's here, is it?
Just there. I think it's that yellow shape, I assume. You're providing some cams to delineate the curve, a warning sign, so that's good. The presence of the access makes it tricky to locate those signs where you'd want to, but with your pavement markings and RRPMs, that all helps. We're in a 40k zone, it appears. So given that, your risks are relatively low, I'd say. Yeah.
And it looks like it's one way, so you shouldn't have too much trouble with vehicles sweeping out and nuisance hits of your system and the like, if they're all sort of entering from that way. Coming in from this way, which doesn't look like it's allowed, would be a challenge. You'd get some nuisance hits on that. So one last one from there. I'm often asked to install barriers in 60-kilometre area by Vic roads when we design New access locations, any comments?
Yeah, look, I'm certainly not opposed to barriers in most cases. 60Ks really is that grey area. We know that a head-on crash with another vehicle of the same mass or with something like a pole at up to 70 k's per hour is unlikely to lead to a serious outcome. There is, of course, opportunity for side impact crashes, which at lower speeds are more of an issue. So 60 k's per hour, look, it depends on your location. If it's a new access and we're perhaps widening the road to provide a right turn treatment or something like that, and you've got power poles that are closer to the road as a result, that's a common situation. So you're increasing the risk presented by some roadside hazards. I can understand wanting to mitigate that risk. An example is boulevards, tree-lined, divided roads in 60 kilometres per hour. Vic Roads guidance says we don't require barriers, but at 70 k's per hour, I think we do. So, look, yeah, 60 k's per hour is probably a bit of a grey area where typically we don't seek to provide barriers.
Excellent. Okay, Jamie, I'm going to have to close it out there. I just want to say thanks to you, Jamie, for your input on this course. Thank you to all our participants. You've really been a wonderful course in terms of a wonderful group in terms of your interaction, answering those questions and getting involved. So thank you so much for that. A really actually a great level of knowledge amongst this group already, and it was good to delve into some of the more tricky situations. We will keep you informed of the those day 2 and 3, or that day 2 and 3 option that you could go to. You'll get emailed a copy of your certificate and sent a physical hard copy of your certificate and any prizes that you've earned along the way. And you will also be emailed a feedback form. We love to hear feedback through this, and we encourage you to share information about the course with others that may be involved in barrier systems or trying to get their head around some of the fundamentals of barrier systems, because they're a wonderful road safety device, and we need to continue to work to get them in the best possible manner to save as many lives and prevent as many serious injuries as possible out there. So thank you very much to all of you. Please do keep in contact with us. We want this conversation to continue. Jamie's he loves a chat about a different tricky scenario in a barrier system. So you've got his contact information. We'll send that around again in the final email. But thank you very much. Have a wonderful weekend, and we look forward to seeing you at the next course.